Hello all. In the last two sessions, we were discussing about the property of electromagnetic radiations and how the light behaves when they interact with some molecules. Now, here, as a continuation to understand the spectroscopy, we need to know the Beer-Lambert'S law. So what is Beer-Lambert'S law? The Beer-Lambert'S law, we also call as Beer's law, is a relationship between alternation of light through a substance and the property of the substance. So the definitions of transmission and absorption of the light by a substance are first introduced by his explanation with Beer-Lambert'S law. So consider this a cuvette which contains some liquid substance, and the incident light is represented as I0 and the transmitted light is I. So whatever incident light enters into the sample, some part of it may get observed and the remaining light will be transmitted out, which we call as I. And the length of the cuvette is represented as L. So here, what are the transmission and absorptions? So considering the monochromatic light when transmitted through a solution, some part can be observed by the solution and some part may be transmitted by the solution. Here, transmission is given as I by I0 and absorption is given as log I0 by I to the base 10 or minus logarithmic scale of the transmission. That is, transmission is inversely represented with absorption. See the differences here. Here absorption is given as 5 and here absorption is given as 3 and here absorption is given as 1. So what is the difference here? So in absorption equal to 1, more light is get absorbed, and in 3 it reduces, and in 5 it's very low. It can be related with the concentration. When more the concentration, more will be the absorption. So the Beer-Lambert'S formula is represented like this here. Log to the base 10 I0 by I is absorption is equal to epsilon L C. So we already said log I0 by I to the base 10 is an absorption. So the formula can be rewritten as A is equal to epsilon CL. So A is absorption and epsilon is a molar absorption coefficient and C is a molar concentration of the solution which we take, and L is the optical path length. That means this L, length of the cuvette or the container in which the sample is present. So Beer-Lambert'S law is a linear relationship between the absorption and the concentration, molar absorption coefficient, and the optical path length of a solution. To demonstrate this linear dependence of the solution, we have taken the 5 different concentration of rhodamin B in water and measured by using a dual beam spectrophotometer. And from these absorption spectra, a linear calibration curve of the absorption versus the concentration was created, since the absorption is directly related with the concentration. So this is the rhodamin B curves. In x-axis, graph 1 in the left side, x-axis wavelength is there. The wavelength is between 450 to 600. And in the y-axis, it is absorption. See at the bottom, the red color line, 38 micromolarity concentration. The absorption is less. And when the concentration increases, the absorption is going on increasing, which represents or proves the Beer-Lambert'S law. The absorption is directly proportional to concentration. When we plot a graph for this, with the absorption and the concentration, we get a linear straight line. By using this type of graph, we can also identify the unknown concentration of a solution. If we are taking an unknown concentration of this rhodamine B and we are measuring an absorption, the peak will be somewhere in the absorption length. Maximum absorption will be there. So that value can be plotted here. And the intersection of these lines will give the unknown concentration. So Beer-Lambert's law is also been used to understand the behavior of light with the concentration, and also it is applied to understand the unknown concentration of a substance. So what are the limitations of Beer-Lambert's law? So Beer-Lambert's law is useful only for a dilute solution. When we go for a higher concentrated solution, Beer-Lambert's law is not applicable because high concentration, more absorption will be there, unable to understand the property of the liquid. There should not be scattering of light beam. If any dust particles or any solid particles, if they are in the solution, scattering happens, that affects the absorption coefficient. And a constant monochromatic light is to be used to understand these concepts. So here we discussed the Beer-Lambert's law and how the Beer-Lambert's law is useful to understand the property of the substance and what is absorption and transmission and what is the formula to understand the Beer-Lambert's law. Thank you.